Okay. All right. So, number one, for all values of x with -2 less than or equal to x less than or equal to 2, the first derivative is positive and increasing. So I'm going to jot a little note here. F prime is positive and increasing. When I look at the data tables are all about f, little f, right? They've told me f prime is positive and increasing. I want to get some hands on this. What do you know about f? F prime is positive and increasing. What do you know because of all the hard work that we've done so far in this unit? If f prime is positive and increasing, Abel, one thing you know.
F is increasing.
F is increasing and, Salma, what's the other thing? F prime is increasing, F is?
No, concave.
Which one?
Concave.
Concave up. Okay, is everybody okay with that connection? Now, normally you have a graph that you can look at, or maybe you have an equation. What's going to make this one harder is there's 5 data tables here, and you've got to decide which one has the f values, the y values, increasing and concave up. What are the smarticle particles telling you to do? I'll take anything from anybody. I want to know where f is increasing and concave up. Trust your smarticle particles. Wonka, what would you do?
Make a graph, like from like your points, you could graph that.
Is everybody okay with that? Right, you could plot some points. Now, to be a really good grapher, that's going to take you some time. That's going to slow you down. It's not wrong. That could work. What else? What else? Brianna, what else do you see?
I would look at f of x and see whether the y coordinates are going down or
The y values here are 3, -1, -4, -6, -7. How would I describe those y values?
decreasing.
They're doing what? They're not negative. They are decreasing. Right? So over here, decreasing. Is anybody going to pick A?
No.
No, don't pick A. It can't possibly be A. But how about B?
Yes.
The y values are -3, -2, 0, 3, 7. They're increasing, so it could be. Over here, -11, -9, -7, -5, -3.
Yes. That's increasing.
That's increasing, so it could be +4, +2, -1, -5, -10.
No.
Decreasing, not going to take that, get that out of there. And then this last one, -3, +1, +4, what is that, +6, +7? Increasing. So here's the thing. Without actually doing too terribly much calculus, you have gone from 5 answer choices down to 3. Is everybody pretty much okay? Here's the part that I just want to have a conversation about. This concave up means something really special. When I say a graph is concave up, I know you guys all know that that's what concave up looks like. We have done this to death. The part that people often forget about is that it tells you something about the slopes. If I look at tangent lines or if I consider secant lines, what happens to the slope? Over here, the slopes are negative, less negative, less negative, 0. Positive, positive, more positive, right? What happens to the slope?
They're increasing.
The slopes are increasing. So a way for me to decide, is my answer B, is it C, or is it E, is to look at slope. What's the slope between these 2 points? The y value increased by 1, the x value increased by 1, the slope is 1. Over here, increased by 2, increased by 1, slope is 2. Went up by 3, went up by 1, slope is 3. Slope's going to be 4. In this data table, my slopes are increasing, which is what I would expect to see with concave up. Concave up means I am bending in such a way that my slopes are increasing. So the right answer choice? B. This guy over here goes with statement number 1. Table.
So if the slope did increase on that one, you would do the same test for the other slopes?
Right, if the slopes were decreasing, if it went like +4, +3, +2, if the slopes were decreasing, I'd say, oh, it can't be this one. Okay?
The same thing would have if the slope is constant.
And if the slope is constant, what would that mean? You guys have a word for this. You've had a word for this for a long time. Slope is constant. There's only one function that you guys know of where the slope is constant. You've known this since 8th grade. Linear lines. So if you see that the slopes are constant, that's not concave up, that's not concave down, it's not bending. It's just a line. Okay? I want to get out of your way. I want to give you guys 4 minutes to make the remaining matches. So start with the verbal description, kind of pull it apart, like what does it tell you, and then figure out where do we go. 4 minutes. Enjoy the ride. You can definitely work with a partner on this. 4, 6, 10, 12, 16.
Literally, C and D are wrong.
Stay good enough for my job. Yeah, good enough for my job.
For the second one, the slope is D.
On my teeth, because you don't have your gears, so you don't have
It's either D or A.
I think it's
But it says that it's strictly decreasing, so it's below that x-axis.
This is constant, right?
It does not.
No, we're
You can
moving on
confuse
to
when
finding out which
the positive one increasing.
I'm wondering which function is it talking about, f or f prime?
F.
So f is strictly decreasing and concave down.
Yes.
Okay, so the x values need to be decreasing as well.
Yeah, you're right.
It says either the A or D.
This is F. This is F. This is
Oh,
talking about
this is
F. So
concave
F is
down.
strictly
Is the
It is
slope with
concave
this
down.
decreasing?
Strictly decreasing and concave down.
Yeah.
This is
That's the thing.
first
I want
derivative. This is positive.
like
This one doesn't say
really
derivative.
fast in the theory.
I think
Function is strictly decreasing.
So on the second one, we know that for all values of x, the function is strictly decreasing and concave down. Love it. So we know concave down and decreasing. So what's happening with the slopes?
Concave down, concave
The slopes are decreasing and the y values are decreasing, right? Usually the like function increasing, decreasing part winds up being pretty easy, right? Because you can look at the y values, you can scan it, and you're like, oh, they're going up, they're going down, I'm done. But it's looking at the slopes, that's the important piece. Nice.
because for this one, it says -3, maybe it says -1. So the slope is actually increasing.
You already found those.
Oh my God. It's different because it's asking you questions.
I was trying to do in the.
For which one?
For this one,
Now we don't want to talk about slope is decreasing.
So it's D.
What does it mean when the function is decreasing?
it's on the negative side.
They're not
Like
gonna
the graph, the function will be on the.
So I'm looking for the
I can
slope.
want the slope to be
Okay, so the number 3, it says that
The slopes are gonna be
You guys are completely.
I think you're overthinking it. Because the thing is, this is F, right? So we're just using that F is decreasing and it's concentrating down. Which means that F is
the slope
And then negative
We're
4.
the only ones that are decreasing on
Yes, slope.
Okay, F prime is positive, that's
Stop it. Stop it.
F
It
is
should be decreasing,
Yeah.
that means that it's decreasing over time, right?
And it's always, and it's only
Wait, slope is decreasing the whole time, not the bad thing.
No.
so the slopes are decreasing.
So,
He's
It's
low.
gonna be negative.
It's either A or D.
Last
You don't need to
period,
find
folks
F
were trying to
no,
know
because
It gives you F right here. It gives you F right here.
you're saying
It's
it's
right
decreasing.
here.
No, but that means the bad news are decreasing.
Concave up means that it's decreasing.
And you know that concave down means that the slope is decreasing. So you have to find the slope.
This
How are we doing?
I think it's
Like how we
increasing,
did
so
right
that's
here.
automatic.
Here,
Right
So
here.
only
So for these two
No, it can't be
Anything
because the slope
else?
is increasing.
1, 2, and 3.
Okay, so statement number 2 goes with D. I agree. Statement number 3, first derivative is
It's A
positive,
because
which means the function is
right
increasing.
here.
Second derivative is negative, so the function
it's
is
equal.
But is the slope
concave
increasing?
No,
down.
on an A is.
So I need slopes to be
I
decreasing.
mean, on these, it's either A or D. But it
No,
also
not the sword.
Alrighty, friends. Number 2, the function is strictly decreasing in concave down. Let's stop all the side conversations, although they're all about math, and I just love you all for that. If I had a heart, it would smile. Okay? The original function is strictly decreasing in concave down. Can you guys show that to me in the air? Strictly decreasing in concave down. Decreasing in concave down. Right? If you do that, that's concave down, but that's not decreasing. Decreasing concave down has to look something like that. So I'm looking for my y values to get smaller and my slopes to
Increase.
the slopes become more negative. More negative. More and more and more and more negative. So the only one that works for is D. Okay, number 3, for all values of x, the first derivative is positive and the second derivative is negative. If f prime is positive, I saw in a lot of papers f is increasing. F double prime is negative, that means f is concave down. So increasing concave down looks like that. Y values getting bigger, slopes
Less positive.
right, positive, less positive, less positive, 0. The slopes should all be positive, but less positive, like getting closer to 0. So which one is that?
E. I don't know. E. It's E.
E?
C or E?
E, right? The y values are -3, +1, +4, but the slopes, it's 4 over 1, 3 over 1. They're getting less positive, so this guy here is option 3. Option 4, for all values of x, function is monotone increasing. This is boring increasing. It just, I increase, that's all I do. And the second derivative is 0. Not positive, not negative, 0. Second derivative is 0. What does that mean, Josue? He's Josue, you're 1.
Want the answer or the?
If your second derivative is 0,
There's no slope.
there's, careful, there is slope. The slope is 0. This would be no slope.
Yeah, that.
Okay.
Slope is 0.
If the second derivative is equal to 0, then your first derivative is a constant, and your original function has to be a line. It would have to be a line. Anyway, and so I think we already identified that one earlier.
See?
That. This guy over here?
Yes.
Okay, and so if all goes well, then you get number 5 for free. All right, let's put your money where your mouth is, shall we? For some of you, that's going to take a lot of money. All right, problem number 2 on the back, 90 seconds. Problem number 2. Completely on your own, no help from anybody. Last year when I did this, I only had 3 people in a class of 25 that got it right. Let's see what we can do. Don't be scared to fail. Embrace it. How many of y'all are finished and feel pretty good about your answer? All right, a little more time. The part that I hope is easy. F is a function, F prime is positive, big F is increasing. And I need concave, what is that, concave up? Which means slopes are increasing. If nothing else, I would hope that everyone would look at the y values and say, okay, if the function's increasing, y values here, -3, -4, -6, -9, I'm not going to pick A. -3, -1, +3, 19, those y values are increasing. -3, 0, 3, 6, increasing. -3, 5, 11, 13, increasing. -3, -4, -3, 0. That's not it. Quick show of hands. How many of you are deciding between B, C, and D? It has to be B, C, or D. Nothing else would make sense. So then the next pass is F is concave up. Look at those slopes. What's happening with the slopes here? The change from -3 to -1 is an increase of 2 every time the x increases by 1. An increase of 4 every time we increase by 1. An increase of 16 every time we increase by 1. The slopes are increasing. So B would be the right answer. How many guys honestly had B? Got 1, 2, 3, 4, 5. Okay, here's what I want you guys to do. For those of you that got it right, try number 1 and then number 3. For those of you that didn't get it right, now would be a great time to ask questions. Oh, so sad. So what are the, if you got it right, go for number 1 or number 3. If you got it wrong, it must be that you've got a question or two. Claudia, what are your thoughts here? Did you get it down to either B, C, or D?
Mm-hmm.
Okay. So then, were you okay with identifying that F was going to be concave up? Okay. So if F is concave up, I'm looking for the slopes to be increasing. Is everybody okay with that part? Okay, hold on a little bit. So Irene, if you're looking for slopes to be increasing, how are you going to make that decision?
Look for the y-axis and look at the numbers and see if they're going to a positive number.
Okay, but it's the key here is it's the slopes that are increasing. So I'm not looking at just the y values anymore. I've got to think slope. What's the slope between these 2 points? I look at like the change in the y, and I look at the change in the x. The change in the y, the change in the x. The change in the y, the change in the x. The slopes are going to be 2, 4, then 16. The slopes are increasing. So that's why I'm going to go with B. All right, see what you can do at number 1. There's something a little bit tricky on question number 1. You're looking at slope. There's something that happens in question number 1 that has not happened in any of the other problems. Look at those x values. So what makes number 1 a little bit trickier, not impossibly trickier, but a little bit trickier, right, the change over here, I'm increasing by 1.2, I'm increasing by 1.8. I'm seeing that happening on a lot of papers. But you also have to pay attention to what's happening over here with the x values. The x values are increasing by 2, and then they're increasing by 2 again. So the slope is 1.2 divided by 2, which is 0.6. Here, the slope is 1.8 divided by 2, which is 0.9. They tell you that f double prime is positive, so f prime is increasing and f is concave up. If your slopes are increasing, could the slope at 3 be 0.6?
No.
Right? It was 0.6 from 1 to 3 and 0.9 from 3 to 5. If my slopes are supposed to be increasing, it can't be A. It could be B. It can't be C. D is too big. E is too big. It has to be B. Do not let this be the thing that totally freaks you out. I did this last because the 20 minutes that we spent on this is about all the time